Welcome back to another episode of Molecule of the Moment podcast. In each episode, we examine the story behind and applications of significant molecules throughout history. Today, we'll be analyzing one of the most common molecules used in modern medicine, lidocaine, with expert Mason Barrett.
Thanks for having me, Connor. I'm very excited to share the story of such a fascinating molecule with you today.
Well, let's begin by taking a peek at the development of lidocaine. Tell me, what's the story behind its discovery?
Great question. The story behind lidocaine starts in Central Asia, where camels were first noticed to refuse eating a certain plant containing gramine, which caused numbness. Fast forward to Sweden in 1943, where chemists Niels Lofgren and Bengt Lundqvist were attempting to synthesize a chemical analog to isogramine, which was discovered to have anesthetic properties after it was accidentally created in the lab. As Lofgren and Lundqvist narrowed down potential candidates, they selected lidocaine, named and marketed as xylocaine, with chemical formula C14H22N2O, as the most useful and effective. It was finally released and advertised in 1949 as the first amino-amide type local anesthetic.
Incredible. So, can you explain a little more of how the local anesthetic property of lidocaine functions?
Sure, lidocaine, as a local anesthetic, blocks pain in a certain area of the body depending on the dosage. The medication halts this response in neurons by delaying and blocking the voltage gated sodium channels, which prevent an action potential from being reached and sending any signals back to the brain. Since sodium ions can't make it through the channel in time, the threshold isn't surpassed and the neuron stays at rest.
That's amazing. Could you give a brief overview of some of the everyday uses of lidocaine?
Of course, lidocaine has a few usages both in and out of the hospital. At home, it is included in many over the counter pain relief creams and patches like Aspercreme, mainly to numb problematic aches such as back and foot pain. Inside the hospital, it is often injected into the skin, next to, or directly inside of wounds to prevent pain during minor surgical procedures such as suturing lacerations or removing foreign bodies.
It's very interesting. Lidocaine is such a universally useful and practical molecule. But I have to ask, how has lidocaine been able to contribute to our understanding of science and medicine overall?
It certainly has had a significant impact. As such a widespread molecule in the field of medicine, lidocaine is often used for research purposes. Connecting to the mechanism of action that I'd mentioned earlier, studying lidocaine's effects helped us in discovering and refining the exact system of nerve signal transmission. Similarly, its ability to block sodium channels has helped us understand channelopathies, diseases caused by dysfunctional ion channels, as a model drug for experimentation. Not only is lidocaine useful for anesthesia, it is also a class 1B antiarrhythmic, which means it can help regulate and stop irregular heartbeats by modifying the electrical signals in cardiac cells. This has allowed scientists and physicians to explore and better understand the electrophysiology of the heart.
All right, it looks like our time's up. Thank you so much for the in depth explanation, Mason.
No problem. Thank you for the opportunity to share the story of lidocaine.
Tune in to next week's Molecule of the Moment if you want to grow your knowledge of chemistry. And thank you for watching.